everyone, welcome back. The learning goal for this video is to be able to identify a reaction as combination, decomposition, single replacement, double replacement, or combustion. And we see all these different types of reactions happening around us. For example, when a candle burns using oxygen and air, that's an example of a combustion reaction. Now, once again, chemical reactions can be classified as combination, decomposition, single replacement, double replacement, and combustion. Some reactions may fit into more than one reaction type, and this is a core chemistry skill, being able to classify types of chemical reactions, because as scientists, we try to see patterns. If we can establish patterns, then we can predict, for example, how a chemical reaction will behave, what type of products it will produce, just based on classifying it in one of these 5 example reactions. So let's start with combination. So combination occurs when 2 or more elements form one product. So this happens when simple compounds combine to form one product. Here you see an example of sulfur, elemental sulfur, reacting with oxygen. Remember, oxygen is one of the diatomic molecules that occurs in nature. And then when those two react together, they form sulfur dioxide gas. Here's some other examples here. Magnesium reacting with oxygen to produce magnesium oxide. Notice how these reactions are all balanced, which was a core chemistry skill you learned in a previous lecture video. So you'll use your skill in balancing equations throughout this video and future videos as well. Here we have sodium plus chlorine gas to produce sodium chloride, sulfur trioxide plus water to produce sulfuric acid. So just notice the pattern. Simply, it's 2 or more elements forming one product. 2 or more elements forming one product. Here's a common reaction we like to do in the lab where we take a magnesium metal. And so this magnesium metal strip is only made up of magnesium atoms. And then when we light it on fire, it reacts in the presence of oxygen in our atmosphere. Remember that delta stands for heat. So that's like lighting it on fire, applying that heat energy. And then when that magnesium strip burns, what's left over, it looks like a white strip, like coated with like almost like a white powder. And that's the magnesium oxide that's formed after this combination reaction. Decomposition is the opposite of combination. This is when one substance splits into 2 or more simpler substances. For example, let's say we had reactant AB and then it broke down into products A and B. Here's a couple of other examples where we have this mercury oxide breaking down into mercury and oxygen gas. And so the key pattern here, one product producing one reactant producing 2 or more products. Here's the example of the mercury 2 oxide. When heat is added, it will break down and decompose into mercury and oxygen gas. So we see the oxygen gas is bubbling off. It's a little harder to see, but the mercury metal is kind of forming actually at the surface here. You can see the silver mercury liquid there. As that mercury 2 oxide, this yellow substance here, is decomposing and breaking down. A single replacement reaction is when one element takes the place of a different element in another reacting compound. So for example, we have element A and then compound B and C, and then A switch places with B. So now we have product AC and then element B. I like to think of this as like a dance. And so you're just switching partners, but only one switch is happening versus double replacement when two switches are happening. So here are some examples: zinc metal reacting with hydrochloric acid. And then notice how the zinc switches places with the hydrogen. So now we have zinc chloride and then hydrogen gas. And then here we have iron plus copper 2 sulfate. The iron switches places with the copper to make iron 2 sulfate and then copper metal. You can see the zinc hydrochloric acid reaction here. So basically we're taking a metal strip of zinc and inserting it into concentrated hydrochloric acid. And if you do that, immediately you'll start to see bubbles form. The bubbles are the hydrogen gas. And what's happening also on the surface, which is a little bit harder to see, is that the zinc is dissolving too into zinc chloride because it's aqueous, meaning it's dissolving into water. So basically the metal strip will start to dissolve over time in the hydrochloric acid. Double replacement reactions is when two elements replace each other. So we switch partners here. So if we had compound A and B and compound C and D, then A will then react with D. So they will take partners here and make AD, and then B will react with C to make a compound there. So they are both switching places there. And so in these examples here, we have silver nitrate, sodium chloride. So the silver partners up with the chloride to make silver chloride, and the sodium partners up with the nitrate to make sodium nitrate. It's really important with these double replacement reactions that you're only reacting the cation with the anion. You'll never form silver with sodium because they're both cations and like charges don't really like each other. So it's the positive ions that find the anions in the other compounds. So silver with chloride, not with sodium, because they don't like each other. Opposites are attracted. And then the sodium with the nitrate. Notice how the positive cations that are highlighted here are always out in front. So this is where you're going to use that core chemistry skill, predicting ionic formulas that we learned in a previous unit, previous lecture video. And so that will be crucial to predicting the products of these reactions. Zinc 2 sulfide here, reacting with hydrochloric acid. Once again, the cations are zinc and hydrogen. Zinc then partners up with the anion of the other compound, so zinc chloride, and then hydrogen partners up with the anion here, sulfur, so hydrogen sulfide. My apologies for the typo here. This is not barium sulfate, but rather copper 2 sulfate. So what we have here, we're doing a double replacement reaction. We have a copper 2 sulfate solution that's blue, and we have a zinc strip here. And basically what will happen is that we'll insert the zinc and it will switch partners. So the copper will switch places with the zinc. So you'll form zinc 2 sulfate. And so let me write that down. So initially we had copper 2 sulfate. And then we're adding the zinc metal here. And then we're forming zinc 2 sulfate, aqueous plus copper metal. This is technically actually an example, more of a single replacement reaction here, my apologies. But basically that copper switching places with the zinc, and then we can see the formation of the copper metal. So I apologize, this is more of an example of a single replacement reaction as opposed to a double replacement reaction. What you'll see with a double replacement reaction, as you can see in these examples here, we have two ionic compounds and then producing two different ionic compounds, right? As opposed to having something that's elemental as a reactant and as a product. So that's the single replacement example there. We'll see some examples later on in study checks, and we'll keep working together on it. So combustion reaction, this is when we have a carbon-containing compound. It's burning an oxygen to form carbon dioxide and water. And energy is released as a product in the form of heat. This is where you're doing combustion reactions all the time when you're cooking your food. And so it produces a lot of heat energy to cook your food. So for example, if you have a gas stove at home, you have, methane gas, and once you light that on fire, it's producing carbon dioxide and water. But really what you're doing is utilizing that heat energy to cook your food on the gas stove. We also, maybe if you like to grill outside, you have propane. And so propane is C3H8. And then once you light it on fire and oxygen, it still produces carbon dioxide and water. Those are always the products of a combustion reaction that goes to completion. So let's go through a summary of these reaction types. So a combination, you have two or more reactants forming one product. Decomposition, one reactant producing two or more products. Single replacement, you can see here only switching one partner. Double replacements, we need to switch two partners. And then combustion, reacting in the presence of oxygen to produce CO2 and water and heat energy. So let's talk a little bit about the toxicity of carbon monoxide, since we're talking about combustion reactions here. And many of you are going into fire science or nursing. So when a propane heater, a fireplace, or wood stove is used to burn fuel, it's important that we have adequate ventilation. If the oxygen supply is limited, then what occurs is incomplete combustion. And if that happens, then we're producing carbon monoxide. It's not going all the way to CO2, carbon dioxide gas and water. We have carbon monoxide, which is a colorless, odorless, and poisonous gas. Because what it does is it attaches it to the hemoglobin molecules when we inhale it, and it reduces the amount of oxygen that can reach our cells, and it can cause a person to experience a reduction in their exercise capability, visual perception, and manual dexterity. Hemoglobin is the protein in blood that transports oxygen to cells. And so when hemoglobin is bound to carbon monoxide, if that reaches 10%, a person may experience shortness of breath, a mild headache, and drowsiness. If it reaches up to 30%, a person may experience more severe symptoms such as dizziness, mental confusion, severe headache, and nausea. If it reaches 50%, a person could become unconscious and die if not treated immediately with oxygen. So it is reversible if you have oxygen available, but there needs to be a quick response. All right, so what I'd like for you to do is you have your notes with you, and what we want to start to develop is this pattern recognition, looking at any chemical reaction and seeing if you can classify it as one of the following patterns that we just discussed. And so I'd love for you to pause the video, look back at your notes, and try your best at categorizing these chemical reactions as either combination, decomposition, combustion, single replacement, or double replacement. All right, let's check your work. So what I like to do is first kind of rule out the obvious ones. So for part A, I know it's not combustion because I don't have CO2 and water. So immediately I can say, okay, it's not combustion. I can also rule out decomposition or combination because I have, the same number of reactants as products essentially here. And so I have like 2 and 2. So I can rule those out. If I suspect it might be single or double replacement, then what I like to do is actually use a highlighter so I can see who's switching places. So what I mean by that is I'm going to highlight aluminum here in blue and just use different colors. I'm going to do hydrogen in pink, and I'm going to do the sulfate in yellow. And when I do that, I can see, like, it just visually for me, because I'm a visual learner, I can see that the only thing that's changed is that aluminum has switched places with hydrogen. There's only been one switch that's occurred. And so with that, I can classify this as single replacement. The next example we have here, once again, not a combustion, not a combination, not a decomposition, because we have the same number of reactants as products here. So I have to narrow this down to single or double replacement. I'm going to go ahead and use my highlighter trick again. I'm going to start off with sodium in blue and then move on to sulfate. Maybe this one's in pink, doesn't matter. It's arbitrary, the colors. Just helps us kind of see who's switching places. And then nitrate here, I'll have in green. And what I'll notice is that the cation, sodium, has now partnered up with nitrate, so that switched places. And I see the silver has partnered up with the sulfate here. And so the cations have both switched places. So this is an example of double replacement. All right, this one here, I know it's not combustion because the products are not CO2 and water, but it looks like I have two reactants and one product. So what does that one look like? Looks like a combination. When you have two or more reactants making one product, then that's a combination. And then part D, we have a C2H4 reacting with oxygen to produce CO2 and water. This must be what? Combustion. All combustion reactions that go to completion produce carbon dioxide and water. All right, let's do some more practice again. Pause the video, try this one on your own, and then check your work with me when you're done. All right, what did you say for part A? Good, hopefully you said combination, because you have two reactants forming one product. What about for part B? This would be single replacement. Once again, use those highlighters if you have them available, just to see visually who's switching partners. And it looks like we're only getting one switch with between silver and hydrogen. So that's single replacement. What did you get for part C? If you see the product CO2 and water, hopefully you're already saying combustion. There you go. And then the next one, what did you get? Double replacement. Good. And so once again, I'm just going to highlight just to show you that trick. I know it's been helpful for my students in the past to do this. And even just saying that we have 4 different colors, right? Versus single replacement where we only have 3 different colors can be a big clue to this being a double replacement. You see lead is now partnered up with sulfate. So the lead has, switched places with the potassium. The potassium partner up with the chlorine. So this is a double replacement. And then the last example, part E, we have potassium carbonate breaking down into potassium oxide and carbon dioxide. Now, just because you see carbon dioxide, don't automatically assume combustion. It needs to be a hydrocarbon, meaning that it's a carbon and hydrogen kind of molecule plus oxygen to give CO2 and water. But this one doesn't have that. It has one reactant breaking down into two products. How did you classify that? That is decomposition. Good. All right. Thank you for watching. And as always, email me with any questions.